Hello everyone, welcome in. Let's cover some decisions today. It should be a pretty cool day because we're finally going to learn some syntax that will allow us to make decisions. We're finally going to be able to write programs that will branch off into different scenarios. So yeah, let's get started with that. It looks like a small outline for this topic. It's actually kind of dense. It's especially in this decision section. Uh, there's going to be quite some small detail here and there. But by the end of today, I'm hoping folks will understand the differences between these diagrams here. So I'll just display them real quick and go over them in the future. So I have a few diagrams here. This is something we'll cover later. It's an if statement. You can think of it as a branch in the road. And then next we have some more chained if statements. These are more forks in the road. And then later on we'll talk about some if and else statements. These are kind of like, imagine two forks in a single path right here. And then we can add more. We'll talk about something called the else if as well. So yeah, by the end of the day, hopefully we have enough to see the differences between these diagrams. That's the biggest takeaway from today. Okay, as for the supplementary material, I did recommend 1.6 from the recommended resource, the reading. But if that isn't enough, let me just pull it up. Because it might be kind of hard for folks to read. It might seem too long. This is one of the longer sections, 1.6. They cover conditions and conditional operations. It is kind of long. I recommend going through all of it. But if folks are wanting like a different resource, I did go over, I did recommend some W3 schools as well. This is also a good secondary resource. So you could follow along after lecture if you go on the the 1.6, or you could go to the W3 schools. So the W3 schools, this is once again, it's a good secondary resource for learning certain languages. And in particular, they have a Java somewhere here. Let me see. Let me just search up Java, and today we'll be covering if statements. So this section over here, pretty much half of this over here. So yeah, if you need more resources, feel free to take a look at W3 schools. This is arguably a little easier to read. It's kind of organized a little better, and there's some sections. So when you're done with this, you can just click on the next section over here, and it'll go through the else statement. Okay, cool. Yeah, so let's get started. As I was saying, we're finally going to be able to write programs that branch into different scenarios. By branching, we can think of trees. So I'm going to show a few pictures of trees and kind of show some real life applications, like just to kind of motivate this topic a bit. In computer science, you'll hear something about a tree. Specifically, you might hear of a decision tree. These are ways on visualizing control flow. For example, you can imagine a program that starts at the top, and then maybe there's some decision that needs to be made. Depending on what decision is made, we'll go into a sub branch. So there's branches within branches. This is called nesting. All right, let's bring up a real example of a decision tree real quick. You might have remembered COVID from several years ago. I remember I downloaded this application when I was at UCSC as an undergrad. I had to download an application to gain access to certain places on campus. The application was pretty much a decision tree. You would download something on the phone and then answer a few questions. And then based off your answers, you'd be able to have access to certain parts of campus, like the dining halls or maybe some offices. So this is a decision tree right here. One of the first questions the application would ask is, are you having any symptoms? And then it's a yes or no question. You can think of this as a true or false condition. Okay, true or false, meaning if it's true, then we're going to go into this branch here. This is a branch that contains more branches. If the first condition was false, then we would say no, and this would be the This is called a leaf. It's the end of a branch. So yeah, based off this application, if you were to have a false condition on this first one, then testing is not needed, and I'd be able to get access to certain places. All right, so yeah, this is an example of a decision tree. Here's another one. Some people are interested in writing game AI. This is, once again, AI is kind of like an umbrella term. I gave it a more specific term called reflex agents. You can create decision trees where there would be like a bot that kind of plays for you. For example, in Pong, how would you implement a bot? Like, let's say the bottom is a human, and then let's say the top is a bot, like a computer that's going to play for you. Now, how would you design a decision tree to try to beat the player? So there's many decision trees you can write. One of the basic ones is kind of just follow the ball. The bot would check a condition. It would say, hey, is the ball left the paddle? If it's yes, then move the paddle left. And then if it is not, then we'll branch off into a different scenario where it can possibly move right. So this is a reflex agent. It's like a simple AI. It's called reflex agent because the AI can really only think one move ahead. You could implement a reflex agent for chess if you wanted to, but it's going to be really dumb. It can only look one move ahead. Okay, let's bring up another example of decision trees. If you've ever signed up for a credit card, or maybe you wanted to get approved for a loan, some companies or banks will use a decision tree. This isn't really a good representation of it because different companies are different, I think. But you can imagine if you were to apply for credit, there's some conditions that you got to meet. Like you got to have a good credit history. Maybe your income has to be a certain amount. Maybe your length of the credit history has to be a certain time. So yeah, these are all features that are implemented in decision tree. And if you were to meet certain criteria, then you'd be approved for certain amounts of credit. All right. Hopefully people are getting a sense of what decision trees are. Okay. So this is a very big topic for this course, control flow. One of the first ways we'll control flow is with if statements. If statements is a way of branching into different scenarios. Before we learn if statements, there's a couple prerequisites that we should probably understand first. First, let's get this down. These are relational operators. You can think of them as like math symbols. Last week we used the addition operator, we used the subtraction, multiplication, division. But today these are kind of the same operators, but they're going to yield a different result. They're going to yield something called a boolean. A boolean is true or false. So for example, here, let me pull up the J shell. So this is something I showed last week. Feel free to take a look at the previous recording. I'm going to load up my J shell real quick. This is going to help us test out single liners. Okay, here, let me build up to it. On week 1, we talked about mathematical operations. Like, this is a mathematical operation, 1 plus 1. This is adding 2 integers, and the J shell will evaluate it and give us 2. Right, don't worry about this $1 here. This is just the it's just the environment keeping track of history. But yeah, 1 plus 1 is 2. We can do other things like add strings. 1 plus 1, this gives us 1, 1. So these are mathematical operations. This one is it's called string concatenation. But let's talk about these symbols now. These symbols, they don't yield the values like integer. This one yields an integer, this one yields a string. But if we were to use these relational operators, it's going to yield a boolean. Meaning if I were to, for some reason, if I were to compare 1 and 2, so this is an expression. I'm the expression 1 less than 2. What does this evaluate to? This evaluates to true. Okay, so yeah, this is called a boolean. A boolean is a type in Java, and it can either be true or false. So if I were to flip the sign here, 1 greater than 2, this evaluates to false because the expression is not true. All right. We have many other operators too, like the less than equal to, greater than equal to, and then the equals. There's 2 of them here. This is kind of a pitfall for some folks who are starting. In some languages, they use 2 equal signs for comparison. This is like this right here. If I were to compare 1 and 1, then we would use 2 equal sign. The reason why we use 2 equal sign is because the single equal sign is already considered an operator. Like if I did 1 is equal to 1 here, this is actually called an assignment operator. Assigning means we take the right and put it to the left. In this case, it's probably going to have an error because, here, let me just press enter. So I have an error here. The reason why is because the assignment operator expects something on the left, like some variable or maybe a memory location. So we're attempting, the J shell is reading this as, hey, store 1 into 1, which doesn't make sense because with the assignment operator, we're typically storing variables. Like if we were to store some number, so I'm going to declare an integer. I'll call it like number is equal to 1. So yeah, this single equal sign is not comparing equality. It's assigning the right to the left. So when I press enter here, we have a variable called number that's equal to 1. And if we were to compare it, we would use 2 equal signs. So numbers equal to 2. Let's see. What is this going to evaluate to? This is false, which makes sense. And then if we were to do it again, numbers equal to 1, it's true because 1 is equal to 1. Okay. Hopefully people are getting a sense on these relational operators. They yield booleans. So I'm just going to Google this real quick because I didn't really talk about it. Boolean in Java. Let me see. I guess I could load up this W3 schools. This is a good secondary resource. A Boolean is a data type. So far we've talked only about integers, doubles, and strings. But you can create a Boolean too, and these store the literals true or false. Okay, yeah, so you could look down here for some more examples, some Booleans. We're going to be using these values to create branches. Okay, cool, so those are some relational operators. This is part of what we need in order to control flow in a program. All right, the second thing we need to know is the notion of scopes. This is not just Java, but in a lot of other programming language, you have something called scopes, which help define the lifetime of certain variables. In Java, they use curly braces. Curly braces can represent lifetime of certain things. For example, this main method, you might have wondered these curly braces. The curly braces, anything inside of it will live there. So if I were to declare any variables inside this main method, it would live there until the end of the curly brace. So when the program gets to the end of the curly brace, you can think of it as they get deleted, kind of. All right, so those are called local variables. You can have global variables as well. This is kind of like a bad programming practice. Let me pull up a VS Code example real quick. Okay, I'm just gonna load up my VS Code. Let's see, what's the last thing we did? I need to sort this by time somehow. It's sorted by ABC order right now. I think the last thing we did was string manipulation. Okay, I think this is it. Okay, so let's talk about the differences between these scopes here, the global and the local. Okay, so far we're only using local scope. Like here in this main here. Let me run this program real quick, just so folks know what it does. So let me cd into examples. Okay. So once again, this program is from last week. All it does is analyze text. In particular, we declared a variable, a hard-coded variable on top. This is a local variable, by the way. It's a local because it only exists within these curly braces. So if there were to be more code, in a couple of weeks we'll do something called methods. Well, we're going to be able to write more things like int method and then another thing here. This is a sneak peek. We're going to be able to write more methods that have functionality in it, and sometimes it's necessary to organize variables where they belong. So in this case, this string variable only exists within these curly braces. It is possible to declare this globally as well, meaning that I could cut this and put it outside of the main method. So I just went ahead and cut and paste over here. This is now you can think of it as a global variable, meaning that almost anything has access to it. I'm going to put quotes around it, by the way. Java is an object-oriented programming language. It treats globals a little differently. But you can think of this as everything can maybe have access to this. It does run. It does Java, and then it gives us the same behavior. The reason why this still works is because we declared it outside the scope, meaning that any inner ones can see it. So you can think of it like an onion. We declared something on the outer part of the onion, and the inner parts can see it somehow. All right, so this is considered a bad programming practice, by the way. One reason is it doesn't really belong here, and another reason is when we write bigger programs, other pieces of the code will be able to touch it. And this can be considered a security hazard if other parts of the code are touching things that shouldn't be touched. So if I were to put this variable back in the main, it's kind of like a protection. So I'm putting it back in the main here. Now this is a local variable, meaning that if you write more code in different files or more methods, it's not going to be able to modify this, which can be considered safe. All right, so yeah, those are scopes. This is useful for the next few weeks. Next week we'll talk about, today we'll talk about if statements, which will use these curly braces. Next week we'll talk about loops. Loops also use these curly braces to declare local scopes. And then in a few weeks from now, we'll talk about methods. This is a main method, but we're gonna make more different types later. And those are also going to require these scopes. All right, so we were just going over the prerequisites in order to control flow in the program. Once again, we need to know relational operators, which are operations to yield some sort of boolean value. And we also need to know scopes, which will declare like a local area that you can work in. All right. Okay, let's jump into it then. We're gonna code our first example in just a bit. But first, here, let me show a few pictures. This is kind of the biggest takeaway from today. I'll show a few pictures and then I'm gonna refer to it back and forth, so you'll see this again. All right, but the biggest takeaway from today is visualizing different flows in a program. We'll first start off by talking about the if statement. The if statement works by checking some sort of condition. A condition is an expression that evaluates to true or false. For example, let me bring up my J shell again. So here's my J shell. When I did something like 1 is less than 2, this is an expression or a condition. In this case, it evaluates it true. So conditions are necessary for if statements. The reason why is because it tells us whether or not it's true or false, which will control whether or not we enter the scope. So here, if the condition is true, the program is going to run the statements inside of the local scope. All right, so that's within these two branches. You can think of this if statement as a fork in the road. All right, if the condition is true, we'll go to the fork, execute the statements in that scope, and then continue on with the rest of the program. All right, if the condition was false, we would not go into this local scope. We would just continue on with the rest of the program. All right, so this is the first one we'll see, but then we're gonna build on this. Sometimes it's necessary to have more complex trees. Sometimes maybe you want to chain. So sometimes you want to chain multiple forks in the road. So you could put multiple if statements right next to each other. You can think of this as three separate trees. All right, this first one, we have a fork in the road, and then we carry on with the rest of the program. Let's say there's another fork in the road. So there's another condition, and here's another fork, right, and so on, more forks. So some people might see this as one tree, but I see it as three different trees that have two branches in each of them. All right, the reason why I'm kind of bringing up the tree stuff is so we can organize our programs and kind of visualize them a little better. Because sometimes it's necessary to represent kind of like more flat trees. Here we'll talk about an if and else. Okay, well we'll introduce it in a bit. Sometimes it's necessary to introduce another fork on this same level. So this is where the else statement comes in hand. An else catches everything where the first one is false. So the first condition here, if this is false for some reason, then yeah, that the else would happen. All right, and this also applies when you add more forks in this same exact road. For example, we have an if statement here, but it's possible to use an else if as well. All right, this is different from the previous slide, by the way. This previous slide uses if and then a plain else here. This later else doesn't have a condition, but in this next one, we see that the else does have a condition. Sometimes it's necessary to specify why we enter in certain branches. So this is where we use an else if. All right, and then finally, you can end off the tree with an else. This is like a catch-all branch. A catch-all meaning that if the earlier ones were false, then the last one would happen. All right, people cool with this? So yeah, that's the biggest takeaway from today, visualizing the differences between all of these diagrams here. All right, let's go ahead and apply this real quick, and it should come together a bit. Okay, this one is meant to be a class exercise, but let's go ahead and do it together, just so folks get a little more warmed up. So let's say we were to write a program that analyzes an integer. For example, if the program says, hey, type a number, and let's say we type in 5 as input. Okay, type in 5, press enter. We should expect the program to describe that integer, like describe it as positive, and then it's an odd number. Or let's say we run the program again with -20. This should give us negative and even. All right, so let's go ahead and practice this, apply this real quick. I'm gonna go ahead and load up my VS Code. Okay, so let me load up my VS Code here. And I'm gonna make a file here. I'll call it integer analyzer .java. Okay, integer analyzer. Okay, we're gonna do this one together. If folks are watching the video, I would recommend maybe pausing it and trying it out yourself if you can. We're gonna see probably like a few different solutions to this. So it might seem like I'm taking too long to go over this class exercise, but I kind of just want to encourage folks and show that there are an infinite amount of ways you can represent the solution. All right, so it might seem overkill and too detailed, but it's going to be very helpful for creativity. Okay, so I create a new file called integer analyzer. Let me set up the main method. Okay, there we go. We have the main method. Let me save it real quick. Okay, let's see what we should do. So this class exercise, we need to prompt the user to type in a number. So let me do a print statement. Okay, let me do a print statement. io.print. I'm not going to use a new line because I want the number to be right next to it. So I'll do io.print and then type a number. Type a number, colon, space. Okay, great. Now we need to handle input. So I'm going to handle that input with a read method. Okay, this is a method that returns a string. So it might be useful to store it. So I'm gonna go ahead and store it by using this assignment operator. I'm gonna store it in a string called user input. The reason why I'm storing it in a string is because this method returns a string on default. So we kind of have to use a string. All right, let me go ahead and test this real quick just to make sure our output and input works. Okay, Java integer analyzer. Okay, type a number, type in 5, enter. Okay, cool. There's no crashes. Great, let's carry on. Now we need to use that input and branch off into different scenarios. This first one, well, whether or not it's negative, positive, or 0, you can think of this as a tree with 3 branches. We are gonna need to compare numbers, by the way. It might be necessary to convert this string to a number. The reason why is so we can properly compare whether or not it's even whether or not it's positive or negative. If we were to leave this as a string, we might get some weird behavior. Like, let me pull up a JShell real quick, just so folks can visualize what's happening. Let's say I had like a string user input, and let's say for some reason it's like 5. Okay, so user input, this is a string, by the way, because I use double quotes. So this is a string. If we were to compare user input with a number, like let's say, is this greater than 0? Okay, so I'm comparing a string with an integer, and the JShell here gives me an error. It says I cannot compare a string with an integer. All right, so we might need to convert it so we can properly check if it's greater than 0. That's part of the problem. The part of the problem is to check if it's greater than 0, less than 0. So let's go ahead and convert this string. One way you can do that is by using this method in a library. There's a library called capital integer, which contains a method called parseInt. And this method takes a string as an argument. So I'm going to go ahead and put the user input string here. All right. Okay. This method does return an integer, by the way, meaning it's probably going to be useful to store it. This way we can work with it later. All right, so I'm going to go ahead and store it into an integer. So I'll call it like int number. Okay, so this is saying, hey, convert. Let me comment this actually. Convert the string to a integer, and the reason why is so we can perform math operations. If we left it as a string, the operations would do string operations, which are a little different. All right. And if folks were wondering how I knew about this method here, you can check out this doc over here. So there's the integer. You could look up integer class in Java. Integer class in Java. Let me click on this first one. Okay. I'm referencing this. Where is it at? It's called parse int. I'm using this method here. So this method takes a string as an argument, and then it returns an integer. That's what this documentation is saying. Okay, let me clean this up a bit. Great, so we converted it. Let me just test it real quick, just to make sure I don't have any errors on this line, like sanity check. All right, so this is a print statement that's going to sanity check. You don't have to do this right here. So I'm just sanity checking the variables. It's a good idea to test it before you move on. So I'm just going to echo it back out. I'm just going to say you typed, and then some number here. All right, sanity checking the variable before we use it. So let me go ahead and test it. So Java, type a number. I'll type in like 5, and then enter. And it says you typed 5. Okay, great. So it looks like our conversion is working. I finished sanity checking the variable. Let's go ahead and implement this first tree here. You can think of this class exercise as implementing 2 trees. One tree that determines the sign, like negative or positive, and then another tree that determines whether or not it's even or odd. All right, that's one way you can visualize this. So let's focus on this first tree. Let's create a couple branches that determine whether or not it's negative or positive. Okay, one way you can do this is by checking if it's greater than 0. If it's greater than 0, the number is positive, and then if it's not greater than 0, then it's probably negative. There is a 0 here. I'll talk about this in just a bit. But let's ignore the 0 for now. Let's keep it simple. All right, let's pretend like we just care whether or not it's negative or positive. All right, so you can think of it as a tree with 2 branches. Okay, one way we can represent this is by using an if statement. We could probably use 2 if statements. All right, let's keep it simple. Let's just use 2 if statements, and then we're going to move on to a more efficient approach. Okay, so yeah, one way we can do this is by creating two separate trees. We can create a tree here. So I just created an if statement, by the way. An if statement uses the parentheses. The condition will go inside the parentheses, and then these curly braces represent the statements that will be executed. So anything within the curly braces is inside of this scope here. All right, so let's go ahead and represent whether or not it's negative. Okay, well we could say, hey, if the number is less than 0, okay, this is a condition. It'll return true or false. If it's true, then the number is probably negative. So then we could output something here. So I'm gonna output the result here, which should say something like negative. So I'll put negative, and then you know what, I'll just test this real quick. So just test this. So let's go and run it. Okay, so compile and run, type a number. I'll type in 5. Okay, I type in enter, and nothing happened. Okay, no output happened. This makes sense because the condition was false. 5 is not greater than 0. This evaluates to false, so we go and proceed to the rest of the program. All right, so you could test this again with like maybe negative 5. So I'll go -5, enter, and it is printing negative. Okay, great. Cool, so we're just sanity checking. In particular, I'm testing each branch. This is a good program practice. As you implement branches, you want to test them just to make sure they're working before you move on to the rest of it. All right, so we tested that. let's go ahead and do the other branch. All right, and I am going to use an if statement, and the reason why I'm going to use an if statement is so we can show a more efficient approach later. This is actually an inefficient approach. I'll explain in just a bit. Okay, so the other one is positive. Let's say if it's greater than 0, then it's positive. Okay, positive. Okay, cool. So this should work. Let me go ahead and test it. So let's test the positive branch now. Let's go like 10. Okay, 10, enter, and great, prints positive. Cool. So these two if statements, these are technically, you can think of it as two separate trees or two forks in the road. Okay, you can think of it as this right here. It's arguably inefficient. The reason why this is inefficient is because if I type in like a negative number, so let me test it again. Let me test it with like -10. All right, so I'll test it with -10, enter. Okay, I did get the correct result. -10 is negative, but this is an inefficient approach because the second branch, the second tree is being checked. Okay, so we typed in -10. This first condition is true. Okay, and then the program is going to proceed and check this as well. There's actually no need to check this. You know what I mean? There's no need to test this condition because the earlier one was already true. So it's inefficient because we're redundantly checking a next branch when it's not going to be true. Okay, so hopefully people kind of see the inefficiency here. It's kind of hard to see until we get into loops. When we talk about loops, it's going to be necessary to make very efficient programs. But one way we can simplify this is by combining the two forks in the road. All right, we can do this by introducing something called an else branch. By using the else, we're combining the two forks in the road. Okay, meaning that I can remove this condition. Okay, we don't have to check this condition anymore. I can just convert this to an else. Okay, by making this an else, these two branches are now technically connected. So I'm going to remove this new line here, just to show that they visualize they are connected. Okay, so by connecting them with this else, this means it's kind of like a catch-all. If the first one is false, then we're just going to branch into this second one here. All right, so let me go ahead and test it. So Java, let me go 10, and oops, I made a mistake here. So I made a typo. I accidentally typed in a non-numeric character, and I got a runtime exception. So let me run the program again with the no typos. Type in 10, and I type in positive. Great, makes sense. Let's go -10, and this is negative. Okay, great, this makes sense. The reason why this is more efficient is because with our negative branch, the first one is true, and so the computer is going to do this, and then it's going to go straight down here. All right, so this local scope will be executed, and then it's going to exit. It's going to exit the tree, which is outside of right here. Okay, this is efficient because we're not redundantly checking the inside. All right, hope that makes sense so far. Let's go ahead and modify this a bit to include the 0. Right now, all we did is negative or positive. So let's go ahead and implement this 0 case. Because currently, if I were to type in 0 here, 0, and then enter, it prints positive. In this class exercise, we're considering 0 to be neither of them. So it should have printed 0 instead of negative or positive. All right. One way we could fix this is by adding another branch on that same level. So this is where the else if will come into play. We'll introduce something called an else if, and then this takes in some sort of condition. All right, so we could convert this positive into an else if branch. So else if, and then I gotta put a condition here because else if takes a condition. In this case, I'm gonna be more specific on the branch. I'll say, hey, else if the number is greater than 0. So this is being specific, which will protect our 0 now. If I were to test it with 0 again, so I'll go 0, now it prints nothing. Earlier it printed positive. So I hope that makes sense why it doesn't do anything now, because neither of these conditions are true. Right, this is false, this is false. So we could do a catch-all branch. You can think of the else statement, this one. This is like a catch-all. If the earlier ones were false, then we're going to execute this inner one. So we could add in another branch, else. In Java, else doesn't take a condition. It's, in this case, it's only if the earlier ones were false, meaning that this is a 0. All right, so there it is. Let me go ahead and test it. So Java, let me type in 0, and there it is. It typed in 0. I mean, it outputted 0. This makes sense. So how this works is this is false. So the computer is going to check the next branch. It's going to say, hey, is this true? No, it's not. And then it's going to, since this is false, we're going to go into the catch-all branch. If the earlier ones were false, we'll do this one. So that's why it's printing 0. All right, this is actually kind of efficient because if I were to use like a negative number, like once again, a negative 10 is negative. This is efficient because the first one is true, and these next ones won't be checked at all. So once again, this first one is true. There's no need to check this next one. All right, that it is not going to be checked, by the way, because we connected them with an else if. All right, people kind of getting the point here. By connecting them with if and else ifs, it's efficient because if an earlier one is true, we're gonna quit. Well, I mean, we're gonna execute the inner part and then quit the tree. All right, yeah. So this is what we're doing here. One tree with 3 branches. It's possible to have more else ifs in between as well. All right. Okay. I'll repeat this again in another example. It's kind of hard to see why it's efficient right now until we move on to loops. Okay, so we're still doing the class exercise. We handled one tree. Okay, once you can think of this problem as implementing 2 trees. So far, we implemented one tree with 3 branches, and now we can implement another tree with 2 branches. Okay, whether or not is even or odd. For this, I'm gonna stick with the else. I mean, if and else. So I'm gonna go ahead and program this. But before that, how do we tell whether or not a number is even or odd? All right, let me. Yeah, how do you determine? There's a certain math operation you can use. All right, let me pull up some slides real quick. This is something from last week that I kind of should have been more detailed. One second, folks. Let me just pull up my slides from last week. Okay. You might remember we talked about some mathematical operations, and there's a plus sign, minus, division. In particular, there's this modulus over here. We barely talked about the point of this modulus. Modulus operation gets the remainder, and it can help us determine whether or not something is even or odd. For example, let me pull up my J shell again. So here's my J shell. I'm just going to use it to visualize some arithmetic. Like let's say 5 mod 2. This is saying what is the remainder when you divide 5 by 2? Right, the remainder is 1 because 2 fits into 5 2 times, and there's remainder 1. All right, let's do another one. Let's go like 10 mod 2. What's the remainder from dividing 10 into 2? There's no remainder, 0. All right, people getting a sense on what the modulus is? You could do like 4. I'll go like 15. Actually, let's go 15 mod 4. All right, this is saying what's the remainder? All right, so it should be 3, I believe, because 4 fits into this 3 times, and then there's 3 left over. So there's 3, and let me just test it one more time. Hopefully people are getting the point. Let's go 6 mod 4. All right, well 4 fits into 6 one time, and there's going to be remainder 2. So 2. All right. We can use this modulus operator to determine whether or not something is even or odd. All you have to do is mod it by 2 and check whether or not it's divisible. If a number is divisible by 2, then it is even number. Like let me put in a random number here. Okay, here's a random number. If I were to mod this by 2, this is like checking if it's divisible. Okay, it gave us remainder 1, meaning that this is not divisible, or it's an odd number. I'll do a different number. So here's another number, mod 2. This is a remainder 0, meaning this is an even number. All right. So yeah, this is one way we can use the modulus operator to determine if it's even or odd. All we have to do is mod it by 2 and compare it to 0 and 1. Okay, let's go ahead and get that branch in then. So this is one tree, by the way. I'm going to represent the next problem as another tree. So it's not going to be connected to this first one. This first one is only for the sign. But then this next one here, I'm going to start off with a plain if statement. First, I'll check if it's even. All right, and you might remember that just mod it by 2 and check if it's equal to 0. So we can go ahead and do that. We can say, hey, if the number mod 2 is equal to 0. All right, so there's kind of two things happening here. This first part is a mathematical operation. It's going to give us a number, and then we're going to compare it against 0. All right. So if the division is equal to 0, if the remainder is equal to 0, then it's even. I'll do a print line here. This way we can go to the next line. Okay, let's go even. And then I might as well code the else here as well. So else, this is like a catch-all. If this first one is false, then it's probably going to be odd. So you could represent this as an else statement. You could also represent it as an else if, by the way. But here is not too necessary, because if the first one is false, then it must be odd. So odd here, and then semicolon. Okay, cool. Let me go ahead and test this. So run the program, and let me test with 5. And 5 is positive odd. Oh, hold up. Yeah, this is right. Let me just add a comma in here. So sometimes it's necessary to be exactly matching the output here. When you go into future programming classes, there's a chance it's going to be fully auto-graded, meaning that they're going to run your program and compare your output. If the output is not matching exactly, the auto-grader will consider it incorrect. So I'm going to try to be exactly like this output over here. So comma, space, and then something. Okay, so over here I'll do a comma, space. Comma, space. This is just one way, by the way. You don't have to do it this way. In my opinion, I would probably create a string and then build it. But here I'm kind of just outputting it along the way. Okay, let me just test this. So Java, and let's go 5, enter. Okay, positive odd, looks good. Let me test the other branch. Let's go -20. Okay, so let me test it again. Let's go -20, enter. Negative even, that looks good. Yeah, that's matching up. Let me test the 0 branch just to make sure. So 0, and then 0, even. 0 is considered even because it's divisible by 2, and I mean because there's no remainder. Okay, hopefully that makes sense so far. So we just did a class exercise together. There are an infinite amount of ways you can represent the solution, by the way. Here I'm representing the solution as 2 trees. The first one contains 3 branches, and next one contains 2. That's right here. So here's the first tree. It starts with an if, and then the next tree here with 2 branches. All right, this is just one way you could represent it. Okay, any questions about this so far? People all good? Okay, great. Let's take a 5-minute break real quick. And then after that, we'll move on to one more application and we should be done. All right, this next application is going to be pretty useful. It should help put almost everything together. All right, we'll do this in just a bit. Be back in 5 minutes though. Put a 5-minute timer. All right, be right back. I'm gonna pause the recording here. All right, welcome back from break, everybody. Let's continue. Let's do one more example. It should put together the major point for today. Now, the major point for today is understanding the differences between this branch right here using multiple if statements. These are disconnected trees. You can think of them as multiple forks in the road. And make sure you see the difference between this and this over here. This is combining those forks onto kind of like one layer. All right, let's do one more example. It should make more sense on why this can be more efficient. Okay, for this one, I'm gonna do a conversion. Say we were to implement a program that just converts a number into a letter grade. So if, let's say the program says, hey, what score did you get? And say we typed in like 100. So we typed in 100, then it should convert that score to A and output like, oh, you got an A. Let's say we run the program again and type in like 85. Right, 85, the program should output, oh, you got a B. Something like this. So I'm actually referencing material from the 1.6. If folks want to take a deeper look at it, you can look at the 1.6. Let me load it up. The 1.6 here. I'm pretty much referencing something down here towards the bottom of the section. They'll go over this programming exercise, grades and points. So it's similar, very similar scenario here. Right, in this case, it's a little simpler. Here they say, hey, if you 37, if type in 37, then that program is going to output grade failed. So yeah, we're going to do something very similar, except we're just going to print out the letter. All right, so let's go ahead and load up a file for this. Let's see, I'm going to create a file. I'll call it grade calculator. .java. This example is going to evolve in a couple of weeks, by the way. So we'll talk about this again. Okay, let me set up the main method. Okay. So here I want to design a program where the user types in a number. So let's do that. Let's do that. Let me prompt the user first. So I'll say something like, what score did you get? What score did you get? And then I'll go ahead and take input. So let me go take input. There's a function method, read line. This does return a string. So I'm gonna store it in a string. There it is. You know, let me just test this real quick. Just wanna make sure it compiles. Okay, cool, it compiles and it runs. What score did you get? Let's say I type in like 100. And when I press enter, the program should say, you got an A. something like that. Okay, let's proceed then. We stored the input in a string. It might be useful to convert it into a number. This way we can properly compare. It might be useful to use a float, by the way. So we've been using integers, but we should probably use like a float or a double. Floats and doubles are the same, except doubles have more precision. So we could convert this into a double. The reason why I want to use a double is because scores can have decimals. You know what I mean? Like the user can type in 80.5, and that would be considered a float. Okay, so I'm gonna go ahead and convert it. One way you can convert it is probably by using the double library. Let me look it up. Double class Java. So double class. I'm gonna end up using this method. It's called parse double, I believe. It's right over here. Yeah, this is a method. Converts a string into a double. A double is a fancy way of saying decimal. So let me go ahead and use that. So double.parse double. It does take a string as an input. So I'm going to use the user input. And this function, this method does return a double. You can see that over here in the documentation here on this left column. It's telling us what it returns. This means it might be useful to store this into a variable so we can use it again later. So I'm going to store into a double variable. I'll call it score. This is a good name for it. All right, so let me go ahead and sanity check this. So I'll go ahead and sanity check, but by printing out the score. So you don't have to do this. Once again, this is a sanity check. All right, you'll see why I did this, because there's room for errors actually. You typed score. Yeah, let me just test this real quick. So Java, let's go 100. Let's go 95 actually. 95.7. 95.7. You typed 95.7. Okay, great. Great. Cool. Let's go ahead and program the branches. So you can envision this as a tree with several branches. This is incomplete, but you can imagine there's an F down here somewhere. Let's go ahead and do this first scenario here. If the score is greater than 90, greater than equal to 90, then we have an A. So I'll go ahead and do that over here. I'll represent a if branch, if statement. Let me get rid of the sanity check. Okay, so we could check if score is greater than or equal to 90, then this must be an A. So I'm gonna go ahead and output, this is an A. io.print letter, I'll just print out, you got an A. All right, this is just one way you can do it. And let me go ahead and test this real quick. So Java, let's say I type in 95.7. You got an A. Okay, cool. Let me test it again with a different number. Let's go like 80. And then 80 doesn't output anything. This makes sense because the first branch is not true. Okay, let's go ahead and proceed with the other branches. All right, I'm going to do this in a different way first so folks see why we use else ifs. Let's say I were to program this other branch but use an if statement. Okay, so let's say I made a separate if statement that checks if score is greater than or equal to 80. All right, so there's gonna be something weird that's gonna happen, and hopefully folks see why. You got a B. All right, let me just test this real quick. So I have two. This is actually like two trees, by the way. It looks like one tree with two branches, but it's more like two trees with, it's like two forks in the road. So this can be weird because if I were to type in like 95, or actually here, let me test the B branch first. Let me go like 85.6. Okay, so if I type in 85.6, this condition should be false. This one should be true. So press enter and it does get the right output. But if I test the program again, check it out. I'll test the program again with like 100. Okay, I'll type in 100. This first one should be true. All right, so let's see. Yeah, that first one is true. But then the second one happens as well. All right. Do people see why this is happening? All right, this is hopefully people see that this is like two forks in the road. It's kind of inappropriate for this solution. It's possible to make it work. You would just have to make this condition a little stronger. But yeah, people see what's happening. When I typed in 100, both of these are true. All right. So one way you could fix this is by combining them into else ifs. All right. So here I'm going to switch back and forth a couple times so people see what I mean. So you could convert this into an else if, which will combine the two branches into a single tree. All right. By using an else if, this says if the first one is true, then the next one won't be checked at all. All right. So if I were to try with again 100, now it properly prints you got an A. Right. The reason is because with this syntax, if an earlier one is true, the next ones won't be checked at all. All right, that's pretty much the biggest point here. Compare that to earlier. If we don't use an else. Right, so I'm gonna delete this else, and now they're technically disconnected. We kind of have two separate trees here. All right, so this gives us the incorrect result. It prints both of these. All right, it is possible to make this work, by the way. You could modify this condition and make it a little more strict. I'll talk about this on Wednesday. On Wednesday, we'll talk about more complex Boolean conditions. For a sneak peek, you could make this more complex by adding an AND here. So this is a Boolean operator where if both sides are true, then the whole thing is true. So you could make this more strict by checking both bounds. You could check the lower bound and the upper bound. All right, so all I did here was make the condition more strict. With this and, this says both sides need to be true in order for the whole thing to be true. So this should work. Java grid calculator, let's go like 100. And then now it only prints this one because the first one is true, but the second one is false. The second one is false because one of the conditions was false here. This condition here made the whole thing false. All right, so it is possible to represent this solution with disconnected trees and forks in the road. But let's talk about this on Wednesday. For now, I'm gonna go ahead and just connect these into an else if. I think this is a better solution because it's more efficient. You don't need to check the next ones if the earlier one is true. All right, so there you go. I just connect the else ifs. Let me go ahead and implement the other ones. So else if score is greater than or equal to 70, you got a B. You got a C, I mean. And yeah, so this is a tree with 3 branches now. And let me test it. Let me test 75. Let's print C. Great. Okay, with this, hopefully people can do the rest of the branches. You can go ahead and do the D branch, the F branch. You should be able to complete it. I'm going to leave this as incomplete for now. Okay. Let me just change this implementation a bit so people are aware of different solutions. You don't have to print on every single branch. You could just create like a result and store it if you wanted to. So instead of these print statements, one thing you could do is prepare a variable. So above this branch, above this tree, I'm gonna prepare a variable, like a string variable. I'll call it like grade, letter grade. All right, so I told the computer, hey, go ahead and allocate memory for a string. I'll call this letter grade. The point of this variable is to store data. In particular, if we enter this branch, we should overwrite letter grade. So this is letter grade is equal to A. Right, so this is overwriting it. I'm assigning the string. I'll do the same here. So this is a B, and then this is a C. And so this is another way. I think it's a little cleaner because now you just need one print statement. All you need to do is output the letter grade at the end of the program. So I'll go ahead and do that. You got a letter grade. Okay, let me go ahead and test this. So Java. Okay, it looks like I got an error message here. Let me check what the error message is. So on line 19, it says error, variable might has not been initialized. Interesting. Okay. Let me save it again, because I did initialize it up here. Oh, you know what? I declared it, but not initialized it. Okay. So it looks like the Java compiler is protecting us from uninitialized variables. This is called an uninitialized variable. And Java is telling us that this has no value. Oh, it does get a value later, but the compiler is protecting us against undefined behavior. If you have uninitialized variables, you can end up with undefined behavior. So one way you can do this is by initializing it, which means to assign it some result. So I'm just going to assign it an empty string for now. So just to see if this works. So I'm assigning an empty string. Let me test it again. And okay, cool. It does compile now. I just use a quick workaround here by initializing it to some dummy value. In this case, is equal to an empty string. Okay, so let me go ahead and test it. Let me go ahead and type in like 100. Type in 100. Letter grade becomes A, and then we just print it out in the end. All right. So yeah, this is just another way. Hold on, let me think real quick. There's something I wanted to mention. Let me think for a minute. Oh, okay. I wanted to mention something about scopes again. So earlier I talked about these curly braces in Java. The curly braces represent the lifetime of a variable. So in this case, notice how I declared. So I declared or initialized, declared a local variable. So I declared a local string variable, and it's declared inside of the main method. So these curly braces in the main, these ones, the letter grade, this variable belongs in the main method, meaning that these next things can see it, because these if statements are also inside the main method. All right, so that's kind of what a local variable in a certain scope means. It's possible to declare things in the wrong spot and have an error. If I were to declare this local variable inside of these inner scopes, something bad might happen. Let's see. So I'm gonna comment this out. Instead of declaring it in the main, well, I'm gonna declare in the main, but inside of this local scope. Right, so let's say I were to say string letter grade here. In Java, if you prefix it, this is declaring. So this is This is declaring, meaning I'm making it exist. I'm gonna do the same here. String, letter grade. Okay. If I were to run this, compile, we get an error message on line 17. Line 17 is right over here. The compiler is saying cannot find a symbol. All right, so this is kind of an important thing for a lot of programming languages, not just Java. It's complaining right here. The compiler is saying, I don't know what this letter grade is. Kind of weird, right? It doesn't know what it is, even though we declared it. Well, however, these are declared in the wrong scope. The scopes define the lifetime of a variable. By declaring the strings in the if statement, the lifetime of a variable only exists in the curly braces. So if I so this does exist, but you can only access it within the same scope. You know what I mean? Like I could get this print statement and copy it. So let me just comment this out. So I could copy it into here, and I'll have to do the same with all of them here. So let me just. Right, so I could do the same with all of those, but we will get the correct behavior. Like 100 gives us an A, 85 gives us a B. This does work. Hopefully people see why it works, because this string only exists within these two curly braces. So this is legal. All right, compared to earlier, let me undo all of this. So I'm gonna do Control Z, undo all of this. All right, so compared to earlier, this gives us a compiler error because of scopes. The scopes is we declared something too local. This is way too local, so the things outside of it, this statement cannot see it. All right. So one way you can fix this is by declaring it outside of it. So I'm going to go ahead and declare it over here. String letter grade. Let's make it empty for now. All right, so once again, this is declaring outside of the scope. In particular, this belongs in the main, meaning that all of these inner ones will be able to see it. All right. So Java, grade calculator, let's go 100, enter, gone A. Let me test the other branches. 85.6. Let me test some more branches. Let's go 70, 79, C. Okay, cool. With this, I'm gonna let people finish the rest of this. You should be able to do the other grades. Okay. So we just did an example that pretty much converts a number into a letter. That's all we did. The biggest takeaway here was to visualize the difference between chaining if statements. So here I'm chaining if statements. These are like forks in the road. This can be considered inefficient depending on the solution you're trying to represent. In our case, it was inefficient because there's no need to check the next ones. You know what I mean? Like if an earlier one was true, there's really no need to check the next ones. So that's why we use the if and else if. This is connecting all of those forks into the same layer. That this is more efficient because if an earlier one is true, the next ones won't be checked at all. All right, so it's a little more efficient. So yeah, that's what this is representing here. Okay, any questions about this so far? Okay, cool. That should be it. Let's see. All right, I think that's enough for today. I was tempted to go over something called nesting, but I think it's a good idea for folks to practice if statements first. If statements, else ifs, and at least understand the differences between all of these. So I would recommend taking a look through the readings for some practices. 1.6 over here, there are some programming exercises you can try out. If that doesn't work out for you, you could also look at W3 Schools. This one is arguably a little easier to read. It's a little more organized. You could take a look through that as well. So yeah, get used to that first, because on the next lecture we'll do something called nesting. Nesting means things within things. So far, we've only designed decision trees that are kind of flat. But on Thursday, we'll do some deeper trees. Deeper means you can have branches within branches. Like here, you can imagine this you can imagine this outer one as branches with two of them, but then each of those branches off into more. So this is called nesting. You got things within things. We'll talk about this on Wednesday. We'll pretty much add another variable to the letter grade example. That's pretty much what we'll do. Okay, cool. Yeah, so it looks like we're halfway done with this. Looks like we're halfway done with decisions. I'm gonna deploy another assignment probably in a couple days. That's gonna apply this. But yeah, that's it for today. We covered all of this stuff over here, and on Thursday we'll do all of this. So we'll do decisions again, but a little deeper, and we'll do a couple more special topics, and that'll be it for this control flow. All right, that's it for today, folks. Thank you for being here, and have a great day. Bye.